Good morning. George Hepworth here, Grover Park Consulting. Today, let's build Mike's mobile library. We'll look at the gallery, which lists all of the publications in Mike's mobile library catalog. Previously, we copied over the header, which is the bar across the top with controls on it. We copied across the filter list, which consists of filters for the title, genre, publisher, and media types. Now we're going to copy over the gallery. The gallery, as you know, is the list of items drawn from either a table directly or through a collection. We're ready to copy over the gallery with all of the controls in the gallery into our development version. Before I do that, I want to make explicit something that we implicitly talked about in previous videos, and that is that some item, well, actually all objects have a parent. In the case of the label for the publication screen title, the publication screen title label, its width was set to the width of the parent, and in this case the parent is the screen. All objects are going to be placed either directly onto the screen, in which case they will have a parent property, or they'll be placed within another object, like a gallery. So a gallery will contain objects. And we can take advantage of the fact that the gallery is the parent of all the controls within it to simply copy the gallery itself, and in doing so bring across all of the controls within it without having to do that individually. So that's what I'm going to do now. In my production version over here, I've selected the gallery, doing Control-C to copy it, dropping it over here into development with Control-V, and as it copies it across, we'll see two things happen. First, the layout is preserved because we have used the same set of principles to define the layout. So even though they're in a completely different screen, the layout of all the controls within this gallery is preserved because they're set in reference to their parent, which is the gallery itself. Therefore, everything fell into exactly the right position, the way I wanted it. The second thing you'll notice is that it populated with items from my gallery, items from my data source, even though I didn't explicitly wire it up here. That's because it also brought along the data source. In a gallery, items is the property which contains or links, or to use an access term, binds our object here, which is the gallery, to its data source. The items come from a collection. And now we're digging into the data. Our data is coming from a collection. I use the prefix COL for collection. So this is the publications collection. I'll explain how I get the collections in a moment. First, I want to explain how we use the collections in this gallery. Remember that a collection is a temporary internal in-memory table. It can have exactly the same layout and structure and records as the source table, or it can be different depending on what use you're going to make of it. The records themselves come from this publications collection, which in turn is based on the publications table. It's filtered in one of three ways. If a variable called genre filter is not equal to 0, then we're going to apply that ID as our filter. What that means is that if we have said filter by a genre, let's say it's genre 3, then that filter will be applied to the records in the publications collection. Any record which has ID value of 3 will be included. Everything else will be excluded. If the genre filter is equal to 0, then we bring in every record which does not have an ID of 0. And since our IDs are based on the SharePoint equivalent of an auto number, they will all be non-zero and all of the records will come in. The second filter, which is applied after the first filter has had its effect, any remaining records are filtered by the publisher filter in the same way. If the publisher filter is not equal to 0, we filter those remaining records by ID equal to the publisher. So if we pick publisher 12, then only those records which have publisher ID of 12 are included in our record set that's made its way this far. Then we apply a third filter. We're cumulatively applying these filters. It's based on media type, and the same logic applies. If it's not equal to 0, we filter on that. If it is equal to 0, we filter on everything that is not equal to that. The result of this is that if we have applied a filter using any one of our filters in the drop-down boxes, that will impact the records that make it through this filter. How do we set this variable? I'll show you that in a second. The next filter that's applied is based on this free-form text field. It's an input box, and whatever the text is in that control will be used to filter publication titles, or the titles of publications which contain that combination of letters. This is a contains search. In Access, we typically have a begins with search. You can write VBA or a function in VBA, I should say, to apply a contains search. Here is just the default way the input box works. So we get the contains search on publication title. So anything that makes it through the first three filters is filtered next against our input box, the publication title, and anything that makes it past those four filters is displayed in the gallery. The next step is to sort, and we're going to sort on a particular variable, either descending or ascending. We'll show you how those get set. So from outer to inner, we have our sort, then we do our search, and the search uses the input box. I think I misspoke a second ago, so let me review that. The search applies only to the input box. The filter applies to these three filters, this inner section. Search is going to be contains, filter is going to be based on the exact match. So that's how we get our records into the gallery. How do we get the records into the collection? Let's go and look at that next. That's done in the start, in on start. We'll scroll down till we come to the section where we begin to create the collections. Okay. I'll come back and explain these three collections in a moment. First, I want to show you the collection which generates our publications collection, or excuse me, the code which generates our publications collection. We've arrived at the section in the OnStart event which generates our collections, excuse me, our publications collection. And I'll briefly go through this. There's an extended video, actually there are 3 videos in which I talk about this technique for generating a collection which can potentially exceed the 2,000 record delegation limit that's set in Power Apps. I won't go through that again in detail. I'll simply go over this and explain as I go what's going on at each step, and I'll leave it to you to go and look up those other videos and look at more depth how this is actually done. By default, the delegation limit is 500. You can set that up to 2,000, and that basically means you can bring in no more than 2,000 records by default through certain delegable functions in Power Apps. And because it's possible that our library will eventually exceed 2,000 volumes, we want to be able to bring in all of those volumes, 2,000, 4,000, 12,000 volumes, and have them available internally. And we create a collection to do that. There's no other reason to do a collection here because of the fact we have, I believe, 27 or something like that. Right now, this is way overkill, but I'm thinking ahead that this might come in useful sometime. We set our variable, the record limit, to 2,000. We clear the existing collection, which means we just dump whatever's in it. Since this is on the onstart, the first time the Power App starts, nothing really happens there because there's nothing in there. But we want to be sure that we're setting to 0. This is kind of reflects my philosophy that we want to leave nothing to chance. Ambiguity is the enemy of a good relational database. We set the first record so that we know the lowest ID that we're going to encounter on the assumption that we're working with auto numbers or the equivalent, and that the lowest ID we find will be the first record, in air quotes. The last record, we do the same thing. So we've got the first and the last record. That should be the maximum. The difference between the first and the last should be the maximum number of records we're going to find. We figure out how many times we're going to have to iterate over that entire table to bring in all of our records, 2,000 at a time. The next step is to calculate a variable containing the maximum number of records we should find. And we generate that by taking the first record ID from the last record ID. That'll give us the range of records we should find based on their ID numbers. I add 1, and I explain why I do that in the other video. And that gives us the maximum number of events, or the maximum number of records that we should encounter in this collection. We clear out this temporary collection. We use a clear collect. A clear collect does two things. First, it dumps whatever is in there already and then refills it. So it clears and then collects new. We collect our records from a tally table. A tally table should be familiar to relational database application designers. I won't explain it here. Refer you back to the other videos. Then we iterate using for all. For all, we create a new collection called recursion count. We filter that down from the number of iterations and the tally count that we just generated. The effect of this is to generate a collection with one record for each of the iterations we're going to have to go through. And as we show you here, we need 2 iterations. And this collection recursion count tells us we're going to have to iterate twice. The next step is to use the same for all. We're going to operate over all of the elements in this new collection, and we're going to collect the first and last record in each span. So if we've got 2,000 records and we want to bring that in 2 chunks, it'll be record 1 through 1,000 in iteration 1. That will be last and first in that. And then the second iteration will be item 1001 through 2000 in that second iteration. and that's calculated here. First item is item 1. The last item is 27. Then we go from 28 to 54. This reflects the fact that we have 27 items, and we really only need to iterate once over the entire table to get them all. But because we may have added and deleted records, the actual ID value of the last record may be greater than the 27 records. And so this allows us to extend our iteration or our recursion to ensure that we get whatever is in that last iteration. We're going to use those iteration spans to collect their items into our publications collection. We filter it first by the first item and the last item. So that ensures that we've got everything. And each of our items, 1 through 27, and then 28 through 54, will be collected into this collection. Now we have a collection in memory, and as you can see here, this is the full collection with all of the records, with all of the fields in all of those records represented. That collection now can be used as the items in a gallery, or the data source for a gallery. And if it happens to exceed the 2,000 record limit of a delegable function, we still have all of them because we're using the collection rather than a call to the table itself. If we look at the items again, our collection, which now, as we know from looking at the OnStart, contains 27 records, is the items for this gallery. We can sort it, we can filter it, and we can use that as the basis for future efforts, more specifically editing. I'll come back in my next video and show you how the filtering works against this gallery. Now that we have both pieces in place, the gallery and the filters, we can do a little bit of show and tell on how the gallery works. Please, if you like what you see in these videos, subscribe to my channel and hit the like button. That lets me know that you're interested in seeing more. Until next time, thank you very much.